All right, today we're going to look at section 2.2, rational function key features. However, today we're going to look at these key features from an equation. So after today's lesson, your goal is to be able to identify vertical asymptotes, horizontal asymptotes, wholes, zeros, and the domain from looking at a rational equation. So we're going to start with a little bit of review from yesterday. Yesterday we looked at graphs only in order to identify key features. So some of the key features we looked at were vertical asymptotes, and that is our line that's going straight up and down here. And this line is a vertical asymptote. So it's where the graph is approaching and getting really close, but it is never going to touch it or cross it. It's like its boundary. Think if you were a kid playing at home and you're not allowed to run into the street. That is your boundary. You can't go into it and you can't cross over it. We also looked at horizontal asymptotes, and horizontal asymptotes is our horizontal line that our graph can approach, get really close to, but never touch or cross. We also looked at wholes. So remember, that's a place on the graph that is removable. Doesn't have any points there. It's not a continuous function, so we can see that that whole is going to be right here. And then something else we looked at were our x-intercepts, and we should know from all our different types of functions before, the x-intercept is where our graph is going to cross our x-axis here. So remember, vertical asymptotes are equations of a vertical line. So this vertical asymptote would be x equals -3. Our horizontal asymptote would be the equation of our horizontal line, and on this graph it would be at y equals 2. Our whole, we can't tell exactly where it's at on here, but we do know it is when x equals 1, and our x-intercept here is where it crosses the x-axis at -3. So next we're going to take a look at this same graph, but we're going to look at the function and this equation to find all these pieces of key information. So today we're going to look at finding key information from rational functions if we're only given the function. So the important thing to note is anytime we're given a rational function, when we want to find our key information, we need to have our function in factored form. So from our homework, we actually did factor this. So this function factors into 2 times x plus 2 times x minus 3, all divided by x plus 3, x minus 3. This is what we're going to use to find all of our pieces of key information. The first key feature we're going to look at is finding the domain. Now remember, the domain is a list of possible x values. And if we look at our function here, we have a bunch of x values. So our domain is always going to start off with all real numbers. And if we can remember from our graph yesterday, there's an exception to all real numbers, and we need to figure out what that is. So if we're looking at our function here, we have a fraction. So if we think about fractions, what is not possible? Well, it's not possible to have a denominator that is equal to 0, because then our function becomes undefined. So think about it. Domain, denominator, denominator, domain. They both start with d's, so that's what we're looking for when we're looking for domain. So in our denominator, we have x plus 3 and x minus 3. We know that they can't be 0, so our first piece, if we plug in a 3, or if we plug in a -3, we have 0. So we know that x cannot be -3 because that will give us 0 in the denominator. If we plug in +3 to the second piece, we also are given 0. So we can't have +3 in our domain either. So our domain here is all real numbers, except x cannot be -3 and x cannot be 3. So always think domain, denominator. Next, we're going to look at finding holes in the graph. So we have a hole if a factor in the numerator can cancel with a factor in the denominator. So remember, we're always looking at factored form. So we want to see, do we have something that's the same on the top and on the bottom? In this case, we can see we have x minus 3 on the top and x minus 3 on the bottom. So those two factors are going to cancel, which means we have a hole at x equals 3. But if we can remember from looking at our graph, our hole is actually an ordered pair. So we have x equals 3, but we have to figure out, well, what's our y coordinate? So our y is, we have an input of 3, we want to figure out what our output's going to be. So these canceled our x minus 3's, so we have what's left. So what's left is 2 times x plus 2 all over x plus 3. And 3 is going to be our input, so we're going to plug that in. So we have 2 times 3 plus 2 divided by 3 plus 3. So when we simplify this, we have 2 times 5, which is going to give us 10 over 6. So our y value reduced is going to be 5 over 3, because we can take a 2 out of the top and out of the bottom. So our whole as an ordered pair is going to be 3 5/3. So when we think whole, we're thinking what can cancel on the top and the bottom. The next thing we want to find is, do we have any zeros? So finding the zeros, or our x-intercepts, is when the numerator is 0. So as we saw in our last slide, we canceled out x minus 3, so we're left with 2 times x plus 2 on the top in the numerator. So it says that our 0 is when the numerator is equal to 0. So we have 2 times x plus 2, and we want to set that equal to 0. So when our numerator is 0, that is when we have an x-intercept. So if I solve this, when I divide by 2, I still get 0, and I subtract over 2, I get x is equal to -2. This is where it is going to cross the x-axis. My x-intercept, or my 0, is at x equals -2. And we're coming down to our last two pieces, our vertical and horizontal asymptotes. So when we are looking for our vertical asymptote, it's like finding the domain after canceling the whole. So here, our whole canceled, and we're left with 2 times x plus 2 on the top and x plus 3 on the bottom. We use the top piece to find the 0. We're going to use the remaining bottom piece to find our vertical asymptote. So x plus 3 is going to help us find our vertical asymptote. So it is going to be at x equals -3. Remember, it's the opposite when we're solving. And it is a line, so we need to make sure that we have it as x equals -3 because it's going to be a vertical line. And finally, we're going to find horizontal asymptotes if they exist. So when looking for horizontal asymptotes, you need to focus on the degree. So when we're looking at degree, if we had something that was x squared plus 2x, our degree would be 2. If we had x squared plus x cubed, our degree would be 3. We're always looking at the largest exponent when we're talking about degree. Now, horizontal asymptote is probably the most difficult because it involves a little bit of memorization. We have 3 different cases that are possible for horizontal asymptotes. So case number 1 is if the degree on the top is smaller. Case number 2 is if the degree on the bottom is smaller. And case number 3 is if the degree on the top and the bottom are the same. So case 1, if the degree on top is smaller, then we have a horizontal asymptote at y equals 0. That's always going to be true. Case number 2, if the degree on the bottom is smaller, then we're going to have no horizontal asymptote. And case number 3, if we have the degree on the top and the bottom the same, we're going to look at our coefficients out in front. So, for example, if we had 3x squared over x squared, we're going to look at the coefficients out in front. So we would have 3 over 1, so our horizontal asymptote would be at y equals 3. So a nice little fun way to try and remember this, and if you use it every time, I swear it'll stick in your head. So for case number 1, if we have the smaller degree over the larger degree, it's at 0. So we have slow. If the degree on the bottom is smaller, then we have the larger one on top, the smaller on the bottom, and we have no horizontal asymptote. We have listener. And the degree on top and bottom are the same. We have south side of Chicago. So slow, listener, south side, Chicago. That's going to help you remember. As silly as it seems, you have small over large is 0, large over small is none, and same is going to be looking at the coefficients. So if we look at this example that we've been going through for horizontal asymptotes, we want to look at our x's. How many x's do we have on the top and how many do we have on the bottom? That's going to tell us what the degree is. So since we have 2 x's on the top, our degree is going to be x squared. And since we have 2 x's on the bottom, our degree is going to be a 2 as well. So we have same, so we have south side of Chicago. So we're looking at our coefficients. And our coefficients out in front, we have a 2 and a 1. So 2 divided by 1 is going to give us 2. So our horizontal asymptote is going to be at y equals 2. Just like with vertical asymptotes, horizontal asymptotes are also aligned, so we need to make sure we have that equation, y equals 2. So putting it all together, looking at this one function, this one rational, we can find all these pieces of information. So we found the domain by looking at the denominator. And by looking at the denominator, we can see that we have all real numbers except x could not be -3 or x could not be +3. Our whole was at 3 5/3. Remember, our whole was what canceled, and then we plugged into the simplified version to find our y coordinate. Our 0 was at x equals -2 because we looked at what was remaining in the numerator. Our horizontal asymptote was at x equals -3 from looking at what's left in our denominator. And our horizontal asymptote was at y equals 2. And we got that because our degrees were the same, so we looked out in front at our coefficients to give us what our horizontal asymptote was going to be. So I know that was a lot. So you may have to pause, go back, and re-watch some of this to make sure we're getting all of the important information. So our summary here, the steps we're going to go through every time when we're trying to find these key features is first, factor. If it's not given to you in factored form, you got to make sure that we go through and find the different factors because that is the only way that we're going to be able to complete the rest of our list. 2, find the wholes. So think, can anything cancel out? 3, find x-intercepts. When is the numerator 0? 4, find vertical asymptotes. When is the denominator 0? And finally, find the horizontal asymptotes. Think slow, listener, and south side Chicago. All right, so putting that summary to use, we're going to go through an example together. So we want to find all the key features of this rational. Luckily, it's already given to us in factored form, saves us a step. So starting with our domain, remember, domain denominator. We always start off with all real numbers, and then we want to think, what is our exception? And here our exception is that x cannot equal 2, because if I plug in 2, I get a 0 in the denominator. Which means x also cannot equal -4, because if I plug that in, I also get a 0, which gives me an undefined answer, which we know we can't have. Next, I'm going to look for my wholes. So the wholes is when I have two factors that cancel out. So here, my x minus 2's are the same on the top and the bottom. Those are going to cancel, so that's where my whole is going to come from. So I know that I'm at x equals 2. So to find out what y is going to be, I have to plug it in to what's left. So on the top, I have x plus 3. So if I put in my 2, I have 2 plus 3 on the top. On the bottom, I'm left with x plus 4. So if I plug in a 2, I'm left with 2 plus 4. So when I simplify this, I'm left with 5/6. So my whole is going to be at 2 5/6. After I find my whole, I'm going to find my zeros. And my zero is going to be, looking at my numerator, what's left, when is that going to be 0? So that is going to be 0 at -3. And then finally, I'm going to look at my vertical and horizontal asymptotes. So my vertical asymptote is what's remaining in the denominator. And in the denominator, I have x plus 4. So when is that going to be 0? It's at -4. So my vertical asymptote, remember, is a line. So x equals -4. And last but not least is my horizontal asymptote. So I have 2 x's on the top. I have 2 x's on the bottom. So they are the same. So I'm thinking South Side Chicago. So if they're the same, I'm looking at the coefficients. So out in front, I have that imaginary 1 on the top and the bottom. So my horizontal asymptote is going to be the equation to a line at y equals 1. So that is everything we're looking for when we're looking at a rational function. Now for this problem, it's not given to you in factored form. So we get to go through the fun of factoring to get it down to factored form before being able to identify all these key features. For this problem, the last one, I'd like you guys to write this down, pause the video, try to find all the key features on your own, press play, and we'll go through the answers. So our first step as we go through is to factor. So I need to factor the top and the bottom. So if I factor the top, I have 2 terms, and all I can see is that I can take out a GCF. Both terms have 2 x's in common, so I can take out an x squared on the top, and when I do that, I'm left with 3 plus x. On the bottom, I have 3 terms starting with x squared, so I'm going to factor using the AM method. So I want to think what is going to add to 2 and multiply to -3. So the only things that multiply to 3 are going to be 1 and 3. So in order to get a positive 2, I'm going to have plus 3 and minus 1. So now I'm down to factored form. I can figure out these 5 key features. So starting with the domain, I'm looking at the denominator. So I have all real numbers with the exception of x cannot be -3 and x cannot be 1, because when I plug those into my denominator, it gives me 0. and 0 in the denominator is undefined. The next thing I'm going to look at is what cancels. Well, I have an x plus 3 and a 3 plus x. Remember, commutative property, if we switch them, they're both x plus 3. So those are going to cancel, and I'm going to have x equals 3 for my whole, and when I plug in 3, I can find my y value. So I have 3 squared over 3 minus 1. So I end up with 9 over 2 as my y value. So my whole is going to be at 3 9 halves. So now I'm going to look at what I have left, and zeros comes from my numerator, and what's left is x squared. So x squared is going to equal 0 at 0. So I have a 0 at x equals 0. And my vertical asymptote, I'm looking at what's left in the bottom, in the denominator. And I have x minus 1. So x minus 1, how do I get that to 0? Is if x is equal to 1. Remember, it's an equation of a line, so I need to have x equals. And last but not least, I have horizontal asymptotes. So if I look on the top, if I look at it when it's not in factored form, I can see that I have 3 x's. And on the denominator, I only have 2 as my largest one. So my top is going to be larger than the bottom. So I have large over small. And remember, large over small is listener. So I have no horizontal asymptote. So that is possible. I can have none as an answer. And that can happen for any of the different pieces. You might not have a whole, you might not have a vertical asymptote. And if you don't, we just write none.